Okay, sir.
So now, having known about the squirrel starters for induction motors, now we'll slowly move into single phase induction motors. So far we have seen three phase induction motors. Now we'll slowly concentrate on single phase induction motor. So having known three phase, single phase should be very very easy. In three phase, you will have three windings in the stator, and the rotor will have conductors, right? So same way here, instead of having three windings, I'm going to have single winding. See here, it will have a single winding, single phase winding on the stator and a squirrel gauge rotor. So as usual, the rotor is squirrel gauge, you will have a lot of conductors and only you will have a single winding. Single phase means single winding. And you are going to pass AC current through this winding. Okay, so the AC, because of the AC, see the current is also sinusoidal. I is equal to I max cos omega t. So because of this AC current flowing into your stator, you will be having an AC magnetic field set up. And the AC magnetic field is given by this one. F is equal to Fm cos omega t into cos theta. So this cos theta is going to be the power factor. So this magnetic field will be almost proportional to your input current. See, it is also cos omega t. Input current is also cos omega t. The magnetic MMF is also magnetomotive force is also cos omega t. So the frequency will remain the same, and this cos theta you are getting extra because of the power factor of the circuit. And this peak value of Fm is given by N into Im. So N is the number of turns in your winding, and Im is the maximum current which you are going to supply. So I know the formula cos A cos B. I know the formula for cos A cos B. It is cos of A plus half one by two times cos of A plus B plus cos of A minus B. So if you apply that, you get F is equal to half F of cos omega t plus theta plus half F of cos omega t minus theta. Plus theta and minus theta means, what do you understand? What is the meaning of having omega t plus theta and omega t minus theta? What do you understand by these two terms, omega t plus theta and omega t minus theta? When you add plus means, what is the meaning in phasors? With the angle, if you are going to add plus means, what is the meaning?
Lagging leading, sir.
Yes. So which one is lagging? Which one is leading here? Which term? First term is
Minus
lagging
First
or
theta
one
is
is lagging and second one is
reference is cos omega t. With omega t, I'm adding plus theta. So this will be running before this one, right? So first term will be leading. Correct. First term will be leading, and the second term will be lagging. Okay. First term is leading. Okay. Second term will be lagging. See, whenever you have a plus sign in the angle, it is going to be always a leading term. And the minus sign is going to be the lagging term. And I'm going to denote this leading magnetic field by FF. FF is forward field and FB is backward. Forward means it is moving ahead of your actual field, and backward means it is going to move slightly behind the field. So I'm going to decompose my MMF into two components, forward and backward fields in a single phase motor. In three phase, you will have rotating three phase magnetic field. So there you cannot decompose that because already you have a rotating magnetic field. Already you have three phases there. But here in a single phase induction motor, I'm going to decompose the magnetic field into just two fields. One is going to lead my current. Another one is going to lag my current. Okay. So FF and FB are going to be the forward and backward rotating field. But you see the rotating speed is going to be always omega t only. Only the phase angle is going to be different, and each field has a peak MMF of half FM. See the magnitude, half FM is the amplitude here. Here also you have half FM. And the frequency is given by omega. The angle is going to be plus theta for the forward field and minus theta for the backward field. So definitely you're going to have two fields. One is going to lag and one is going to lead the current.